And welcome everybody to the Daily Space Weather Show. I'm your host, Dan, aka Smash-A-Mash, bringing you another edition of the world's most comprehensive daily space weather content and most detailed solar imagery. We've got a little bit of uptick in the X-ray flux, mainly over there on the eastern limb. I feel like I might have mentioned that that's the most likely place to see a large solar flare. Yesterday we did have an M3 event just in the past few hours down there in that southeastern quadrant. We also have a bright spot rising in the northeast, a likely new active region showing up there. Those are the past couple of hours. This is the past 24 hours. And, sunspot number now back over 150. Also a coronal hole rotating in. We'll cover it and lots more. Here we've zoomed in a bit on the equator. And our T-mass, the most active sunspot, is down there in that southeast. So there's a close-up of that. It is the farther northeast of those two sunspot groups that produced that M3 class solar flare. And we'll jump into coronal holes here in a minute. First, some stats. And by the way, thanks for tuning into the Smash News Network, least busted name in news. If you're new to the channel, don't forget to press the subscribe button. And if you're watching the video and hearing these words, press the like button. And after that, press share. Then visit the links below the video in the description. Hit us up on social media. And here comes some space weather stats. 10.7 centimeter radio flux, still at 165 solar flux units. All things considered, we would expect this to be rising at the next update. So there's the past year from solan.info. Again, sunspot number here just rising back up a little bit over 150, following a little bit of a lull in activity. And just a little correction over what I said yesterday. Yesterday I said we can expect these levels of solar activity to continue for the next about 7 or 8 months. These levels or higher for the next 7 to 8 months. Because we do have solar maximum thrown in there, still expecting it sometime in October. Why? Because, well, the length of a solar cycle is extremely well established and extremely unlikely to vary very much. Space Weather Enthusiast Dashboard is not forecasting any geomagnetic storms. We do have a CME on the way, so there was one launched today that is headed in Earth's direction. We'll show you it. It was pretty subtle, and some of our competition may miss it because, well, they're lazy and uninformed. That's the main reason. And it is too early to see any modeling of that on either the NOAA Enlil spiral or on ESAs. So we do expect to see that showing up there on their models shortly, but that may take a few hours yet. As that did happen earlier today. It was quite early today, so it really should be on their models by now, but hey, what can you do? So here are the past 4 hours of Earth's magnetic moment from space, and keep in mind, folks, that the likelihood of major geomagnetic storms is actually kind of low right now, because proximity to the solstice does indeed lower the likelihood of large geomagnetic storms. So here's Earth's magnetic moment from the ground for the past 4 hours. That's our geospace ground magnetic perturbations map. We try to show it daily on these videos. And yeah, things are very geomagnetically calm. Expect a slight uptick in geomagnetic conditions sometime by midday on the 16th. So here's our solstice countdown. Yeah, we're only a week from summer. So make sure you have your summer plans going by now, right? Because in the northern hemisphere, by the time the solstice rolls around, you're already losing sunlight. So don't forget that. It's these are the 2 brightest weeks of the year for the northern hemisphere. KP index is at 1.33. Again, it is quite calm in earthly geospace. The ACE and Discover not turning in any big numbers either, only about 2.5 protons per cubic centimeter at about 337 kilometers per second for the ACE, and quite similar for the Discover. So very calm conditions for space weather at the moment, with an uptick coming sometime by midday on June 16th. GOES magnetometers here are smooth. That's the past 3 days from the GOES 16 and GOES 18. Next, we'll look at the heliosphere. So we are in a small magnetic sector of North Pole orientation here. That is, let's see, that's only likely to last another about 48 hours based on what I see there. Although, keep in mind there is a new active region likely to be rising in the northeast. So here's our line of sight field plot. We are seeing a little bit of motion there of the solar B field over on the left of your screen. That is an indication that we could see the magnetic sector last longer or end more quickly. So here is our coronal hole line of sight field plot. And the coronal hole that's rotating in right now is of North Pole orientation. You'll see it here depicted in green. Let's bring up the last image. There you go. And here is that coronal hole from the epic perspective of the Solar Dynamics Observatory. Now you may notice some events happening there, some likely coronal mass ejections. Those are largely on the far side except for one. There was a CME that came out of this region right here. This region right in here. And yeah, that's earthly directed. So here's a close-up of that coronal hole. You can expect to see an uptick in the solar wind density in about 4 days from that. So you'll see an uptick in the solar wind density, followed by a downtick in the density, and then an uptick in the solar wind velocity, the telltale sign of coronal hole high-speed streams. Next, moving on to sunspots. Again, sunspot number here just getting back above 150. So no real surprise there. We have seen a bit of growth, some moderate growth, especially in that southeastern limb. Really the eastern hemisphere in general is where the action has been. Here's our flare probability monitor and scoreboard. And yeah, not ranking any of those sunspots very high as far as the computerized models. The most likely place for a large solar flare remains sunspot 3712. So that one, the farthest south one there and near the eastern limb, sunspot 3712 is the most likely place for a large solar flare. So despite the largest flare coming from 3713, the magnetic fields do not lie. And so let's take a look at sunspots here from SDO. So there's a great view of sunspots. We've zoomed in on the equator. And we have multiple sunspots now that are larger than planet Earth, at least in terms of their two-dimensional diameter. But that's what's going on. And let's zoom in a little bit on our T-mass, the most active sunspot. So there they are. We'll also show you the magnetogram. Look at all the umbra from that southern sunspot group. If you're wondering about its magnetic complexity, it has been increasing in magnetic complexity, and you can see a lot of magnetic shear there. What I mean by that is you'll see a lot of magnetic fields that are stark white, bordered side by side with pitch black magnetic field regions. Those are the areas that are most likely to produce large solar flares. Magnetic shear. Solar flares are predictable. These are just basic facts. Moving on to energetic particles and solar flares. Proton flux here dipping down. The likelihood of it coming back up anytime soon remains quite low, as we don't see very much activity over there on the western portion of the closest star. So, as far as X-rays go, like I said, the largest flare of the past 24 was an M3. About an M3.2 is what it was. Peak flux was right around 1645 universal time. And let's take a look at flares here briefly, just the southeastern limb from the perspective of SDO. There's our 94 plus 131 angstroms wavelengths combined for you. Again, that is the T-mass, or most active sunspot. Next, a quick forecast for the solar system. You may be wondering where things are. Well, we are too. And before we show CMEs, we like to help people orient themselves to where things are located. We've got a crescent waxing moon at the moment in 1 week. That's where things will be in a week. It'll be very close to solstice time when we make next week's video, and we will have a gibbous waxing by that point on June 20th. Next is our star chart. This is what's going on over our head. You've got Jupiter, you've got Mercury and Venus up there, and also the moon, which should be fairly high in the sky at sunset in your location if you'd like to catch that. Here's our astronomy photo of the day, and this is M66. So yeah, M66, part of the Messier catalog, and it is in the constellation Leo. It is part of the Leo triplet of gravitationally interacting galaxies. There it is, apod.nasa.gov if you want to check it out yourself, and here comes CMEs. Like literally, there is a CME on the way. So this is George Mason University, and early today, you'll see a small halo eruption. And it's a little tough to see here, but when we show our custom coronagraphs, it'll be a little bit more obvious. So here is the LASCO C2 and C3 together. Well, let's just show stereo A here. So early today, there was a coronal mass ejection. It's a little bit stealthy, not easy to see from stereo A at all, so let's move to our custom coronagraphs. So now if you check out this area right here, you'll see just south of this coronal hole, there is a bit of a brightening happening there. That's a CME. That is earthly directed. This closer view will help you out, like right in here. You'll see right there. So quite early in the day today. In fact, yeah, in the first few hours today, that CME erupted. It is likely to have earthly directed components. It is very unlikely to produce any major geomagnetic storm conditions. So that's the scenario. Expect a CME impact to be minor, showing up sometime by midday on June 16th. So that said, let's take a look at filaments next. Yeah, filaments. They remain a significant story here. So while the likelihood of solar flares is going up, filaments are still certainly a thing to keep your eye on. And when I say eye on, well, the pun is intentional. So there's the equatorial zoom. Here's the northern polar region. You see some great prominences up there, no less than 4 of them. Here's a close-up of the equatorial view. Again, look right toward the center there, right early in the video. You'll see a brightening of that active region south of the coronal hole. That was the origin of a coronal mass ejection. Again, it will be a minor impact on the 16th. We also did have a massive crown prominence hanging out around the southern polar region. So there's a view of that. And here are filaments from Big Bear. So lots of filaments here, no super huge filaments. But yeah, it's there are quite a few on the Earth side of the solar disk. They're all fairly modest in size, but they could blast off at any moment. Again, like I said yesterday, solar flares and even sunspots are not required for coronal mass ejections to pop off. Here is our grayscale view. You can see huge prominences there rising in the east. So one in the southeast and one in the northeast. Likely a couple more sunspots are suspending those plasma filaments. An indication more activity is rising. Here are the past couple of hours from the GOES the Go 16 SUVi. And it looks like some flaring is actually popping off right in the center of the solar disk there as well. So activity is ramping up once again. Not a real surprise as we get closer and closer to solar maximum. Here come bonus features, starting out with charging hazards. There is our charging scenario, and we ain't got no charging hazards. The electron flux remains low. We are expecting an uptick in the next 24 hours in the electron flux to moderate levels. So there's the forecast model by NOAA. That should be updated shortly here. And next we'll show the ionosphere. So we have been noting some anomalies in the ionosphere. Let us know in the comments if you think they're bunker worthy. I certainly don't think they're bunker worthy, but there is the raw ionosonde for the previous day. And things are geomagnetically calm in space weather at the moment, so no real fireworks going on in the ionosphere. Here's the anomalygram depicting anomaly in megahertz from a 30-day median. If you follow that negative 45-degree longitude line there at the bottom of the screen, if you follow that up to the South American coast, you'll note that the South Atlantic anomaly has moved to that spot. Again, if you think it's bunker worthy, let us know in the comments. I definitely don't think it's bunker worthy. I'm not really spooked of pole shifts, and frankly, the current geomagnetic situation that we're having on planet Earth, the current pole shift, is not even qualified to be considered a geomagnetic excursion based on the geologic record. So it's quite minor, and it's just as likely to snap back toward the poles as it is to go through and do a proper geomagnetic excursion or a pole flip. Not scared. If you're spooked of pole flips, definitely let us know in the comments. Don't be spooked of pole flips. So here's our Global Ionosphere Nowcast. We are seeing some anomalies in the anomalygrams. But besides that, things are looking pretty normal there. So not sure if that's a calculational problem or what the deal is. We'll show the latest images here to close out today's daily space weather video. So this is gaining some magnetic complexity up here. That's becoming more likely to produce flares. We're actually seeing some more action happening here, and those are becoming more magnetically complex sunspots. And also these groups down here becoming more magnetically complex sunspots. So that's always interesting. And there is the... Yeah, so flare probability has been going up quite a bit. And let's show one more series of images here. How about the SDO magnetogram plus 94 angstroms to close things out? So anyway, thanks for tuning into the daily space weather content. Congratulations on realizing the channel exists. Once again, don't forget to press the like button. If you're new to the channel, press subscribe. Visit the links below the video, press share, etc. We'll see you soon. In the meantime, I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.